In this video, we're continuing from where we left off, which is solving a linear system by graphing. So hopefully you are very comfortable with solving a linear system by graphing by now. And we're going to use that ability to solve a linear system by graphing to look at the three different possible scenarios when you solve a linear system by graphing. Okay, so I don't want to give away the three scenarios, but hopefully you can think about what you did in grade 9 with graphing lines, and hopefully you can come up with the three different scenarios. So if you don't remember what you did in grade 9, just imagine graphing two lines on Cartesian plane and think of the different possible things that can happen. Okay, so give it a minute, pause the video, and when you're ready, we're going to solve these three different linear systems and see what happens. Okay, so my first linear system is y equals 2x minus and y equals 2x minus 5. I'm really tempted to say something, but I won't. Hopefully you notice it. But you know what? We're going to graph both of these lines, okay? And see where they intersect. So, remember last time we talked about finding the intercepts or using the slope-intercept form to find the slope and y-intercept. So this is already given to us in slope-intercept form, so it'd be pretty silly to solve for the x and y-intercept. So yeah, let's just graph the line using the slope and the y-intercept. So the first line has a y-intercept of -1 and a slope of 2. So -1 and a slope of 2. And remember to give yourself more points. It really helps when you sketch the line or graph the line. So 2 up, 1 to the right, 2 up, 1 to the right, because the rise is 2 over 1, which is the same as 2. Okay. That's my first line. So it's y equals 2x minus 1. What my second line? Y equals 2x minus 5. So this one has a y-intercept of -5, and it also has a slope of 2. 2 up, 1 over. 2 up, 1 to the right. 2 up, 1 to the right. You know what? I think that's more than enough. I'm going to try to make that a little prettier. I just really want to emphasize what's the relationship between these two lines. Okay, so hopefully before you started graphing these lines, when you said the equations out loud, y equals 2x minus 1, y equals 2x minus 5, you notice that the two lines would be parallel, right? Because the lines have the exact same slope. They both have a slope of 2. So this is our first scenario, okay? When you have two lines and they are, when you graph them, they end up being parallel to one another, okay? And let's label the axis good measure. Okay, so for case 2, we have the linear system, the first equation being 3y minus 3x equals 9. When I first see this equation, I noticed that, wait a minute, it's not in standard form, nor is it in slope-intercept form. So what we're going to do is change it to slope-intercept form so I can graph the lines like I graphed before. I find the slope, I find the y-intercept, and I'm ready to go. Okay, so 3y minus 3x equals 9. Let's add 3x to both sides. Divide both sides by 3. Beautiful. Now this one, it's really hard to avoid. It's pretty obvious the relationship we have. We have the first equation, when I rearrange it, hey, it's y equals x plus 3. And what about the second equation of the linear system? It's y equals x plus 3. So guess what? You can probably see what's going on. Y equals x plus 3, so y-intercept is 3, slope is 1. So 1 up, 1 to the right, 1 up, 1 to the right, boom, boom, boom. That's plenty of points. I'm going to hopefully get a really nice line over here. Okay. So over here, I want to add that these lines are parallel lines. Okay, now I know I only graph one line, but there's supposed to be two. It's just that one line is on top of the other line. Okay, it lays on top of the other line, so you really just see one, but there are two lines there. So these are called coincident lines. Okay, let's try the arrow there. Okay, so parallel lines, coincident lines. All right, last scenario here. So we got the first scenario being you have two lines which are parallel to one another, and the second scenario is where you have two lines which are coincident lines. All right, so to graph the third linear system or solve this one graphically, unfortunately I have to rearrange both of these equations because none of them are in slope-intercept form. Now I can do what I did in the last lesson, which is intercepts, but I find that it takes too long to find both the intercepts. Not that I can't do it, it's just this way it's easier if I just convert to the slope-intercept form. So y equals minus x plus 1, 3x minus y minus 2 equals 0. It's equal to 3. Sorry, y equals 3x minus 2. Okay, so let's do the first line, y-intercept of 1, and then the slope of negative 1. So down 1, 1 to the right, down 1, 1 to the right. All right, the next one, I'm not going to connect the dots first. I'm going to try to find the point of intersection before I connect the dots. So y-intercept is negative 2, and then the slope is 3. Beautiful. 3, 1, 2, 3. One, two, three. And you know what? I'm going to quickly check something. I want to make sure the solutions are really as ugly as they are. Oh yeah, they are ugly. Okay, and you know what? This is a great example because it highlights why we try not to solve a linear system graphically if you can do it algebraically. Because once I connect the dots, you'll notice something. The point of intersection for these two lines is very hard to read. Okay, now I do know the solution because I did the math, but it is not where the grid lines intersect. So in fact, I'm not even going to try to tell you what the solution is. This just highlights why, or highlights one of the major flaws in solving a linear system graphically. It's just not very accurate. Okay. Because there's potentially many different answers that students can tell me, and I mean, if it's close enough, I'll probably give you full marks. Okay. But saying that, after you find the solution graphically, you can check whether you're right or wrong. But we probably, like I said, when we ask you system graphically, it's going to be where the grid lines intersect. I don't want 20 or 30 different answers. All right, so let me just label the lines, and then we're going to cover the three scenarios. So here is y equals minus x plus 1. This one is y equals, sorry, let's just do x plus y equals 1. And this one is 3x minus y minus 2 equals 0. You can write the equation standard form, but really they're the same equation. They just look different, but they're the same. Okay, so these are the three cases. So in case 1, how many solutions are there? So in case 1, there are no solutions. You get 0 solutions, 0 points of intersection. In case 2, you have infinite solutions, right? In fact, you can argue every point on the line y equals x plus 3 is a solution to the linear system, right? Because the two lines intersect an infinite number of times. They're on top of each other. So you go from no solutions to the other extreme, which is an infinite number of solutions. So I would argue these are the two special scenarios. In case 3, is, to be honest with you, 99% of our examples that we do moving forward will be case 3. There will be one solution to this system. All right, so we want to investigate how you know whether you have case 1, case 2, or case 3. Okay, so are the equations the same? So in case 1, no. In case 2, yes. In case 3, no. Which makes sense because you're only going to get an infinite number of solutions when the equations are the same. Are the slopes the same? In case 1, the two lines have the same slope. In case 2, well, if the equations are the same, of course the slopes are the same. Yes, and in case 3, no. Okay. So I would argue, first ask yourself, are the slopes the same? Because if the slopes are not the same, you're not going to get a special scenario. You're just going to get that plain old boring one solution scenario. But if the slopes of the two lines are the same, then you have to start investigating. Do I have parallel lines or do I have coincident lines? And then you just compare the rest of the equation. So you can basically say, are the y-intercepts also the same? If the y-intercepts are the same, then you have coincident lines, which means infinite solutions. If you have different y-intercepts and same slope, then you have parallel lines, so no solutions. Students also bring up one point. They always ask me, what if the slopes of the two lines are perpendicular? Well, guess what? It's still the plain old boring scenario of case 3, because they're intersecting at one point. The lines are intersecting at a 90-degree angle, but you're still intersecting at only one point. So for the point I made earlier, if the slopes are not the same, it's still one solution. It doesn't matter if the slopes are negative reciprocals to each other. They're not the same. Okay, so that basically covers the 3 different scenarios you can engage in when you work with a linear system. One solution, no solution, or infinite solutions.